This is 4.5. 1, 2, 3, 4.5. ഈ ലൈൻ ഇട്ടുണ്ടായ ചെയ്യാൻ ദേശത്രയും ലൈൻ നോക്കട്ടെ. Okay. Then this is here. It is 9 Okay, ఈ లైన్ రిమూవ్ చేద్దాం. So now So this is the feasible region because the constants which are given are always, and we'll see this equation. This equation is 10x1. This equation, this is 10x1 plus 5x2 greater than or equal to 60, and this line represents this line 2x1 plus 3x2 is greater than or equal to 18. With this equation, this equation is 2x1 plus 3x2 is greater than or equal to 18. It will be shown. So these are the points we call A. These are the solution points. This is B. This is C. Because they should be greater than. That is the reason feasible region lies this side. So the value of the variable should be greater than this means we will find this is the region. That is the reason we are trying to find the values for these things. So this is how we will find out. These are the equations. Solve the following by graphical method. This linear programming problem by graphical method. So there is a limitation of the graphical method. In linear programming problem, we can solve only the problems with two variables using the graphical method, because on a graph we have only two coordinates or two axes, so which can represent only two variables. That is the reason we cannot solve the problems with more than two variables. However, we solve this using the graph. This is the objective function given is maximize z is equal to 5x1 plus 8x2 subject to constraints 2x1 plus 3x2 less than or equal to 30 and 8x1 plus 4x2 is less than or equal to 80. x1 is less than or equal to 6. x2 is less than or equal to 8. So this is the problem, and it is also provided where x1 and x2 are non-negativity constraints. What non-negativity constraints indicate is x1 and x2 cannot assume negative values. Either they should be positive values or they should be 0. So for solving this graphical method, first of all what we need to do is we have to find out the x1 and x2 values for each of the constraints provided. So after that we will represent through some lines and those lines will form a graph, and we will try to find the feasible region. This feasible region will be the solution region. So whether depending upon maximizing function or minimizing function, we have to identify the solution points. Now first thing is step 1 we will see. So first we will see step 1. What is this step 1? Step 1 is converting inequalities into equalities. So our constraints are showing that they are unequal, less than or equal to such kind of inequalities are given. So we try to find out the x1, x2 values by converting them into equalities. So for this equation, for this constraint, if x1 is equal to 0, 3x2 is equal to 30, that means x2 is equal to 10. And then to find out x1 value, if x2 is equal to 0, 2x1 is equal to 30, then x1 is equal to 15. Then for second equation, 8x1 plus 4x2 is equal to 80. If x1 is equal to 0, 4 x2 is equal to 80, then x2 is equal to 20. Then if x2 is equal to 0, then 8x1 is equal to 80, then x1 is equal to 10.